The UNIST Quantum communicates to machine tools using the RS-232 Serial Communication Protocol. The term serial means data is sent one bit at a time. Sending more than one bit at a time is called parallel. RS-232 is a specific serial protocol that defines the wiring and flow control used to send these data bits. It was originally designed to send data between computers using modems and a telephone line, and you will see this legacy as we learn more about the protocol. Let's begin by looking at the wiring. We start with two pieces of equipment that need to communicate with each other. To keep it simple, let's say one only sends and the other only receives. In reality, both sides send and receive, but if you understand how the communication works in one direction, you can apply it to both. Data is generated by the sender, which puts it in a send buffer that temporarily holds the data. To get the data from the sender's buffer to the buffer on the receiver, we need a wire. On the sender side, this is the transmit data or TX wire. On the receiver's end, this is the receive data or RX wire. Once these are connected together, the data can flow from the sender to the receiver. This is the simplest case. But the designers of the RS-232 specification asked a few basic questions. What if, for example, the receiver is missing? In our simple case, the sender would continue to transmit the data to nowhere. So the RS-232 designers added a control wire, which tells the sender that the receiver is there. On the sender side, this wire is called the Data Terminal Ready, or DTR. On the receiver's end, this is called the Data Set Ready, or DSR. When these are connected and the proper voltage is set by the receiver, the sender knows the receiver is there, and once again, data can safely flow. But what if the sender transmits the data too fast? How fast this data is sent is called the baud rate. If the baud rate is so high that the receiver cannot get the data out of its buffer fast enough, the buffer overflows, and once again, data is lost. To counter this, the designers added another control wire so the sender and receiver can coordinate when to send the data. On the sender side, this is the request to send, or RTS. On the receiver side, this is the clear to send, or CTS. With this additional line, the receiver tells the sender when it needs to pause, and buffer overruns are avoided. Using this send-stop signal is known as hardware flow control. The RTS-CTS wire is the hardware that controls when data flows between the devices. For completeness sake, there are two more wires defined in the RS-232 spec. Both of these are related to modems, so seldom used anymore. These are the Data Carrier Detect, or DCD, which tells the modem when an analog signal is being received from another modem, and the Ring Indicator, or RI, that tells the modem that the phone is ringing. Since we're talking about modems, you may be thinking, wait a minute, there are no modems between the Quantum and the machine tool. And you're right. Instead of using modems, you can loop the control wires from the sender side to the receiver side on the same device. And then the device will tell itself that things are ready to go even when there is no modem. Because null is a programmer term for nothing or empty, and there is no modem, this is called a null modem. With a null modem, we're back at the most basic case, and we only need to connect the transmit and receive wires between two devices to transfer data. To be technically accurate, we also need a ground wire to establish where the signal voltages are referenced from. This third wire is called the signal ground, or SG. With these three wires, we can communicate between two RS-232 devices, and the arrangement is descriptively called a three-wire null modem. This is what the Quantum uses. Of course, this means the functions that the control wires handle, making sure there is a device on both ends and that the receiver is ready to receive the data sent, are no longer being done. So another enterprising person figured out you could perform the same flow control function by sending special packets of data over the transmit and receive lines. Using special packets to control when the data is sent, it's called software flow control, and the packets themselves are called X on and X off. When the receiver is ready for data, it sends an X on. When it needs the sender to stop, it sends an X off. This is less reliable than hardware flow control, since the flow control packets themselves are data, but it often works well enough to be worthwhile. With this, you now understand the idea of null modem, how data is sent in both hardware and software flow control. These are the basics of RS-232 serial communication.